glacier melting, loss of habitats, increased rates of skin cancers. What binds all these is the climate change. And the culprit behind climate change is the accumulation of greenhouse gases. Greenhouse gases are gases that are generated by the activity of humans. And they have two actions. When they evaporate and reach the stratosphere, they even cause or make a barrier that prevents the excess heat from dissipating to the outer space and cooling down Earth during the night. Or, on the other hand, they could degrade the ozone layer and make an opening for more ultraviolet rays to enter Earth and to make extra damage to microorganisms or organs. And amongst the famous greenhouse gases is the methyl bromide. And methyl bromide is a gas that is used in agriculture and is made up of one molecule of methane and one bromine, and it's used in soil fumigation. As you see here, the soil is covered with a plastic mulch, and then the gas is diffused underneath, and it's left for a couple of days to interact with the pathogens and kill them. And then when the cover is removed, the gas, being so volatile, it evaporates and it reaches the stratosphere layer and causes damage to the ozone. Now, why is it that harmful to the ozone layer? That's because it's used in huge quantities. And the most or the biggest user of methyl bromide is North American countries, using about 31,000 tons a year, followed by Europe, then Asia, then South American and African countries. And because these countries realize the importance or the damages caused by this pesticide, they congressed in Montreal in 1991, trying to find a solution for this huge problem because it's contributing hugely to the climate change. And they agreed on phasing out methyl bromide within 15 years, that is on 2005. And this was expected because they thought that within 15 years, these countries are going to find the good alternative to methyl bromide, though they didn't succeed because the alternatives, potential alternatives that were suggested, they failed to prove as feasible or as competitive as methyl bromide because they were even as sufficient but not as cheap as methyl bromide, or they were as not efficient but okay, they were feasible, cost efficient, or other costs that didn't make them perfect or feasible alternatives to methyl bromide. And what happens now is that not only methyl bromide is still used, but it is also still produced. So there is a problem that we are facing. And in order to try to solve that problem or to contribute to its solution, I suggested in my research another alternative, which is ozone itself. And ozone is a molecule made up of 3 atoms of oxygen. And what makes it as a good potential alternative to methyl bromide is that it is the most powerful oxidizing agent. That means that it kills pathogens. Now, in order to prove it as a good alternative, I chose indicator targets to try it on and see how efficient it is. And while trying to choose those indicators, they should be qualified with some criteria. First, they have to be soil-borne, because eventually this alternative is going to be used as a soil fumigant. And second, they have to cover a wide spectrum of efficiency as the one covered by methyl bromide. And second, or third, they have to cause economically important losses in the field. And those indicators have been identified by 4. First, it shows fusarium wilt or fusarium, and you can see to the left the damages in the field caused by fusarium, and to the right you see the macrochlamydia and the spores of fusarium. The second target is Phytophthora, and you can see how devastating it is in the field. Here you can see the hypha and the all spores of Phytophthora. The third one is Rhizoctonia, that causes the brown patch symptoms, and you can see here, I don't know how clear it is, but it goes like a patch pattern in the field, and here are the hyphae. And the fourth one is nematodes, that are microscopic worm-like insects that invade the plant's roots and cause these damages in the field. Now, in order to prove ozone as a good alternative to methyl bromide, it has to be qualified with some qualifications far beyond the efficiency that I'm trying to prove in my research. Otherwise, if it doesn't prove to cover all the feasibility criteria, it wouldn't be as efficient, or it wouldn't be the alternative to methyl bromide, and it will fail as the other alternatives that have been tried and failed. And these are, first, efficiency, but second is toxicity. And in regard to ozone, it has to be generated and used on site. That is, it has no risk of spilling out and causing any toxicity to the user or to the transporter, etc. Second, what about the environmental pollution that we are trying to solve in regard to methyl bromide? And what we know is that ozone degenerates at room temperature, a relatively fast time, into oxygen. That means that its byproduct is not only non-toxic, but it's also beneficial to the environment and to the living organisms. And talking about the cost of the generation and the use of ozone in the field, well, at least the generation of ozone necessitates some primary materials that are so available in nature, and they are, relatively speaking, cheap, which are oxygen, compressed oxygen, or water, or compressed air. That is, relatively speaking, to methyl bromide generation, it should be, or it's expected to be less expensive, especially that it shouldn't be stored and then transported and then used on site. So we are saving a lot of small costs during the production and the use of this alternative. So theoretically speaking, it should be, or it's expected to be, less costly. And ozone generators have now been so available, and there has been a big progress in their production lately, so that the use of these generators on site is so practical, and it increases the practicality or practicability of the use of ozone on site. So by proving the efficiency of ozone in killing the pathogens, the targets that I showed, I would be proving the feasibility or the competitiveness of ozone as an alternative to methyl bromide. And by doing so, I will be helping and contributing to stitching the ozone layer, but also, I hope, I'll be contributing to saving the world. Thank you. Welcome to questions.
Cool. Soil fumigation is something that we have been done for a long time. But now we understand a little more what goes on in the soil, and we have more developed varieties for resistant varieties for a few pathogens and better we develop other practices to control plant diseases. And do you believe that extinguishing all the life in a layer of soil from an entire field is a practice that we should keep doing in the future? Is it something that is interesting for us to put research into this to develop this kind of practice?
So your question is whether we should keep continuing to kill all the pathogens in a certain layer in the soil?
We don't do pathogens. When we fumigate,
Yeah,
we kill everything.
Kill everything.
So
Or
that's
we
what I'm
don't.
saying. Is it
Good or
really
bad?
important? Is it something that we really should be thinking on keep doing it?
Well, this is a problem by itself because methyl bromide, it sterilizes the soil. And this means that it kills the pathogens and the good organisms
Yeah.
that are needed in the soil.
Yeah.
Because the soil needs, or the plants need for some organic material to be, or compounds,
Right.
to be mineralized by the microorganisms.
And
by
how
the
does your
beneficial-
method is different?
Well, ozone doesn't kill, doesn't sterilize the soil, but it disinfects the soil, which means that it kills a certain level of pathogens, but not all, and by consequence it doesn't kill all the beneficial microorganisms. And by doing so, it doesn't do the harm that methyl bromide does, but while decreasing the number of pathogens, you decrease them to a level that doesn't reach the pathogenicity threshold, and you prevent them from causing the harm to the plants. And this is exactly what is required. Yes?
You mentioned that ozone is an oxidizing agent. Do you believe that it has a chance of oxidizing various nutrients or other things in the soil that will be necessary for plant material to use to grow, and if that could become a potential problem?
So your question is if ozonation to the soil is contributing to the oxidization of other minerals in the
Mhm.
soil and enriching the soil with these nutrients.
Or depleting the nutrients that are
depleting.
necessary?
Well, that was also tackled in my research. That's why I'm studying the interaction between the organic matter, the texture, the pH, and a few elements in the soil to see how ozone affects them by oxidizing them, and how do they contribute to the success of ozonation, soil ozonation, in reducing the pathogenicity of pathogens. So yes, I'm studying that, but I don't have the answers yet.
Okay, we probably need to move on. Thank you, Nadia.
Zara?